What if I told you that to live forever you'd have to pull the trigger again and again? I know it is a weird way to start a video, but yet the question is very real.
You're holding a pistol wired to the flip of a coin. Heads, it fires. Tails, it clicks.
A straight 50-50 chance. You pull the trigger, you're alive. Again, still here. But how long can you push luck? And if you are that lucky, does it mean you're immortal? What if I told you that you already died 1,000 times today? And yet, here you are, still breathing and watching this video. What if immortality isn't about living forever, but about constantly surviving in the universe where you never truly die? It sounds like science fiction, but quantum physics has something very similar to offer. Let me take you back to 1950s, a time when one man's search for answers would forever change the way we look at reality.
His name was Hugh Everett. Although he wasn't a typical celebrated physicist, his contributions would eventually redefine our understanding of the universe.
In those days, the reigning theory in quantum mechanics was the Copenhagen interpretation. It suggested that particles could exist in multiple states until observed. This led to many thought experiments like Schrödinger's cat. But Everett believed there had to be another way to account for the bizarre probabilistic nature of quantum mechanics.
What if instead of one reality there are infinite realities, each as real as the last? Everett proposed that quantum events like the decay of radioactive atom or wobbling on the quantum level in a flipped coin didn't lead to just one outcome. Instead, the universe splits, creating parallel realities. The universe doesn't choose between possibilities. All possible outcomes exist separately, like a tree with each branch representing a different path it grows, creating new realities with every quantum decision. And thus, the many worlds interpretation was born.
But what does this mean for us, for you? In the multiverse, every time something goes wrong for you, there is another version of yourself somewhere that remains alive. In one universe you didn't make it, in another you're watching this video.
And from your perspective, the only one that matters, you'll always be in the reality where you survive. You'll never know that you're gone. Quantum immortality suggests that from your point of view, you always exist. No matter how many times you flip the coin, you'll always end up in the branch where you survive and live on, forever experiencing life.
But you, the one watching this, can only exist in the world where you never die. The question still stands. Are you immortal? Or is it just the last ghost of yourself in an endless collapsing maze of probability?
Hugh Everett's life wasn't without struggle. Despite his revolutionary ideas, the scientific community largely dismissed the many worlds interpretation, and he didn't gain the recognition he deserved during his lifetime.
But perhaps his work wasn't just about challenging the understanding of quantum physics. It was about his own search for meaning in a chaotic world. Could the multiverse be his answer?
A world where there's always another version of him thriving in a different reality, no matter the tragedy.
And as we contemplate the multiverse and quantum immortality, maybe that's the most chilling and comforting thought of all. In this vast, infinite universe, immortality might not mean never dying. It might just mean that in some reality, we never truly disappear. And again, as much it feels like science fiction, there is actual science behind it.
If you say, why is our universe the way that it is? Why are the laws of nature such that life can exist, for example? Well, the answer might be that all possible combinations of all the laws of nature exist. Every possible universe exists.
The very idea of immortality has been on humanity's minds for ages. Fountains of eternal youth, elixirs of life, the philosopher's stone, all of this have been the goal of many generations.
Like the picture of Dorian Gray bearing the marks of time while he remained untouched, aging spares no one. But unlike a painting on the wall, the changes happen deep inside us, in our cells, our organs, and eventually across the entire body. Mutations occur, hormones go off balance, and tissues accumulate so-called zombie cells which stop dividing but still release harmful inflammatory signals. The immune system weakens, and protein recycling breaks down, increasing the risk of diseases.
But in the end, just as Dorian Gray couldn't escape the fate he had tried to outrun, neither can we, at least not yet.
Aubrey de Grey, a leading voice in longevity research, suggests that the first person to live 2000 has already been born. Pushing boundaries of human lifespan far beyond what we imagine today, that's a vision that began in the 20th century.
Over time, science uncovered the main causes of aging and potential organ failure, and the alchemical quest for a universal elixir of life was replaced by a more scientific step-by-step approach to finding the key to immortality.
We tried to visualize this journey as a timeline of key events, each deserving a separate video because of its impact on various fields of science, medicine, and technology. Here you can see the discovery of DNA structure by Francis Crick and James Watson. This is the groundwork for understanding genetics. Just a year later, the first successful kidney transplant. First heart transplant in 1967. First usage of AI algorithms in medicine, foundation of quantum computing, the Human Genome Project, or here, in 2005, CRISPR was presented. The revolutionary tool offered the possibility of correcting age-related mutations.
All these breakthroughs led to new challenges that pushed medicine and engineering forward. And today, the adventure continues at a breathtaking pace.
Researchers are developing senolytics, drugs that can clear out aging cells, and studying centenarians' DNA for longevity clues. Experiments targeting mitochondria, the cellular power stations that decline with age, also showed promise. Scientists from Hokkaido University boosted mitochondrial activity in animal heart cells, and in Sweden, Karolinska Institute researchers linked mitochondrial tweaks to better metabolism in mice. At the beginning of the 21st century, 3D bioprinting, a groundbreaking technology, made the fabrication of living tissues such as skin, blood vessels, and miniature livers possible.
This incomplete list of fantastic discoveries shows that aging is no longer seen as an inevitable process, but rather as a medical problem that can be solved. Bioengineering, genetics, and regenerative medicine are advancing so rapidly that many scientists believe immortality is no longer science fiction, it's just a matter of time, with one more crucial challenge: technological synergy. Simply put, it's when two or more technologies work together to enhance each other and enable new breakthroughs. Although we are witnessing incredible progress in separate fields, these technologies have not fully achieved synergy.
A significant step toward this was the integration of artificial intelligence. The ability to process vast amounts of data from different fields has become much easier with the increase in computing power and AI-driven analytics. However, the capabilities of traditional computers are held back by the physical laws they rely on.
And so, we loop back where it all began: quantum physics, or more precisely, quantum computing. To understand quantum computing, we need to step into a strange world of quantum mechanics, the physics of very small.
This is a place where particles can be in multiple places at once, pass through solid walls, and even influence each other across vast distances with no apparent connection. It's a world that defies common sense, but it's the foundation of reality itself. Classical computers are confined by the strict framework of binary bits, 1 or 0, on or off, presence or absence. But quantum computers defy this limitation. They harness qubits, which are typically represented by atoms, electrons, or photons, and exist in multiple states at once thanks to a bizarre phenomenon called superposition.
Imagine a big puzzle. Classical computers grind through each possibility one by one, piece by piece, just like us, but faster. A quantum computer, however, can test all the pieces at the same time, instantly finding the correct one. It's not just faster, it's an entirely different way of thinking.
And then there is entanglement, perhaps the strangest thing in nature. When qubits become entangled, they remain mysteriously linked no matter how far apart they are. Change one, and the other responds instantly. Einstein himself called this spooky action at the distance. But this uncanny connection is exactly what makes quantum computers so powerful.
As qubits can exist in a state of 0, 1, or both at the same time, entanglement allows quantum computers to process huge amounts of information in parallel, handle complex, interconnected systems, and solve problems that would take classical machines thousands of years. Just like the puzzle example, but with more difficult and, in our case, life-saving tasks.
In 2019, Google's quantum computer Sycamore made history by achieving quantum supremacy. It completed the calculation in 200 seconds. Same task would have taken the world's most advanced supercomputer at that time around 10,000 years. While the task itself was symbolic, it signaled something far greater, the dawn of a new era of computation, one where quantum machines could tackle problems beyond human understanding.
And what problems could those be? Perhaps the greatest mystery of them all: life itself.
Quantum computers hold the potential to revolutionize medicine, bioengineering, and even life extension, unlocking breakthroughs that were once beyond imagination. These machines can model molecules and biological systems at an atomic scale, accelerating the discovery of drugs and therapies for age-related diseases like Alzheimer's or Parkinson's. In gene therapy, they could simulate genetic changes in record time, predicting their effects and unveiling new ways to combat aging itself.
Drug development could leap forward as quantum algorithms optimize molecular structures for safer, more effective treatments. In bioengineering, they could drive the creation of next-generation materials for 3D printed organs, paving the way for rejection-free transplantations.
Paired with quantum-enhanced AI, these machines could decode medical scans, genetic profiles, and health data with fantastic precision, crafting personalized treatments.
In the quest to extend human life, quantum computing isn't just a tool, it's a potential game changer, bringing science into a new era. But if death is no longer a certainty, does life still have meaning? If someone gains immortality while others do not, what happens to society? Would eternal life be a gift or a curse?
As terrifying as it sounds, we are at the age of a breakthrough that might actually change the game of living completely. Whether it is quantum computing or Dr. Everett's idea of fracturing reality, it all boils down to one simple thing: we just want to live. To make our fleeting life longer, to find a deeper meaning. This drives many people to ideas like terraforming Mars or colonizing other planets to preserve our species. After all, there is a big possibility that we are all alone in the vastness of space, and it would be very sad to realize that if we are gone, there is no one who who would be curious to find answers and just admire the beauty of the universe.
So here we are, on a path paved by decades of discovery, chasing the key to immortality not as a promise, but as a brave vision of what humanity might achieve. Thank you for your time. See you in the next video.